Welcome back. In this video we will be looking into multi-class classification, one versus rest and one versus one. Let's get started. So first let's look into why we need multi-class SVM. By default, standard SVM is binary, which means that we are only looking at is it category A or is it category B. But oftentimes we don't only have two categories, we can have an algorithm that needs to determine which one of the face of three people we're talking about. So if we have Alice, Bob and Charlie, we need to see if is this Alice, is this Bob or Charlie, but with only using default SVM this would not be possible, and that's why we need to introduce non-binary classification. And we can use one of two approaches. One of them is one versus rest, and the other one is one versus one. And this will help us with handling multiple classes using SVM. So let's first look at one versus rest. In the example that I mentioned, so we have Alice, Bob or Charlie. If it's one versus rest, then we are only looking at is this picture Alice or not. So we are taking the one category that we are interested in, and everything else is just the rest. And the only thing that we want to see is if it belongs to the Alice category or the one that's everything else. We train k separate SVMs, each classifying one class versus all the other classes. And each classifier outputs a confidence score, and then the class with the highest score is the one that we select as our result. So for example, is it Alice or not? Then it would say, oh, it's not Alice. Then we look at, is it Bob or not? It would say it's more confident that it is Bob. And is it Charlie or not? It's more confident that it's not Charlie. And if we take all of these together, then the algorithm is most confident in that it is Bob. So our output would be Bob. Now in the other example, when we're talking one versus one, we are taking two of the classes, two of the groups. So from our Alice, Bob and Charlie example, we would just ask, is it Alice or is it Bob? And we would disregard all the other instances. So we are not interested in Charlie in this category. So we train one support vector machine per a pair of classes. So if we are talking about k classes, then we need k times k minus 1 divided by 2 classifiers, because we need all the possible pairs that we can find. And the order doesn't matter. Alice or Bob is the same as Bob or Alice. This uses a majority voting system. So the prediction runs all the SVMs and returns the one with the most wins, with the most commonly answered thing. So if we take, is it Alice or Bob? It will say it's Alice. Is it Bob or Charlie? We'll say Charlie. And then we ask, is it Alice or Charlie? And it will answer Charlie. So in this case, the most commonly answered thing is Charlie, which means that we will output Charlie. For OVO, so one versus one, it is efficient for small data sets, but scales poorly for many classes, because we need to look at all the combinations of all the pairs, and if only one of them is the answer, then a lot of the combinations are uninteresting to us. And one versus all in comparison is computationally cheaper, but might have overlapping decision regions. That's it for multi-class classification. I hope you can now tell the difference between one versus one and one versus rest, and understand why and when we use them. If you have any questions, you can drop them in the comment section, and I'll see you in the next one.